what I'd like to do today is kind of kick off the session with our view of machine analytics and how it's driving knowledge discovery in the production machinery operations. Okay. So as we all know, manufacturing operations typically have manufacturing goals, and we're talking about quality, productivity, reliability, performance prediction, and even today we're talking about including in that portfolio of goals energy minimization, or some people call it energy optimization, as well as today it's even becoming important to reduce safety incidents. A lot of these goals are somewhat competing against each other in terms of driving the overall output within a manufacturing operation. Even more so today, what we're finding is the future holds a little bit. What this chart is trying to explain to you is that there's the process engineers which set up the production lines or initial production lines, the operators, and even the maintenance technicians. What we're finding over time, this skill is being depleted in the manufacturing operations. And so what we envision in the future, skill sets start to become reduced. And all of that type of operator input that we've relied on today to be somewhat of an early warning and detection system for production problems will start to deteriorate. So the other thing we're finding is some of the traditional statistical process control techniques are having diminishing returns within these operations as well. So what we need to do is find a solution which can address this loss of operator knowledge, the diminishing returns from some of the techniques that have been employed for 40 years in the manufacturing operations. So some of the metrics that we typically see in these operations today, for example, to try to manage productivity are still what I would call relatively primitive. But OEE, for example, which is quite often used to really provide a metric for availability, performance, and quality, all wrapped in one metric. What this doesn't do for you is really identify root cause problems, identify really what's the source of the problem. So what we're finding, this is a good metric, but not providing those real returns on improving operations today. What we need to do is kind of get beyond this flat line of manufacturing intelligence that we're at today. And we believe that analytics will get us beyond this flat line that we're at. We want to get beyond where we have diminishing returns and find new ways of creating knowledge through analytics and bring it back into the manufacturing operations. So what we're looking for is analytical tools that can rapidly recognize trends in production. So they'll be looking at historicals as well as continuous flow of information coming from the various pieces of equipment. So what we need to do is shorten that time from when our process, our production is going out of spec and bringing it back into spec, because there could be hundreds of particular control parameters that may be associated with driving a production process out of spec. The other thing is more and more companies, if you think about it, are moving from long production runs to more or less batch operations. And this ranges from tire production, which, there used to be a lot of inventory store, but now they're going to just-in-time production. Whether you're going into, even automotive facilities where production runs are just simply becoming shorter. So what does that mean? We need to rapidly identify startup problems, because loss in production on the front end of startup problems is too much of a cost. So this means today we want to drive our operations toward a data-driven decisions and instilling within your environment the notion that we're collecting data and we can take corrective actions based on analysis performed on the data. And the other part of it is we want to decouple the operator as much as possible. Decouple the operator from providing the knowledge that they've brought in over the years, because we want to become less dependent on it. I'm not saying it's not great to have great operators that know things, but we need to be decoupled. So a lot of times you see, this is kind of the loop you see in the manufacturing operations today, is the operator has skills and there's certain knowledge that can't be imputed into the operational equipment to really solve some of those really difficult problems. I'll give you an example. I mean, there's one application, particularly in stamping in the automotive industry, when they stamp, the hoods of a car and get it ready for the paint shop. Well, there's no way to detect whether, in fact, the surface quality on that piece of metal is actually truly ready for the paint operations. In fact, it depends upon the operator's feel of that particular piece of metal. And there's no way to measure that. There's no way that they've been able to put a sensor on it and detect, that's a good piece of stamping. So they are in the loop for early detection of where on the die that stamps out that particular hood part. And there are many other examples like that, whether it's in the machine tool industry where you're cutting a part and you start to hear chatter or certain vibrations, sounds that just aren't normally there. So the operator has become an integral part of that early detection of problems occurring in the system. So what we want to use is analytics to identify some of these really obscure, difficult problems that are incurred in the manufacturing operations today. And so we want to use them to determine, the root causes of product quality deficiencies. There can be hundreds of really critical and critical process parameters that need to be addressed to really keep the quality in line. So what we need is more intelligence, more analytics to really identify the critical parameters that are driving a system out of spec. And then furthermore, we need to be able to predict, because what's happening today is incoming raw materials are often inconsistent. So how can we predict how to configure a manufacturing or a production line based on these raw materials, which are somewhat are not within the normal specifications or within a range of specifications that we can manufacture with? So there's a lot of things that we're looking to achieve with analytics in terms of identification of root causes and as well as setup of the machine. Furthermore, we totally expect the analytics will take us to a new area where we can predict failures or degradation in equipment as it's going forward. So fundamentally, just wanted to kind of give a feeling for what some of these analytical techniques are using today. We're talking about regression analysis, looking in the past and kind of moving it into the future in terms of analyzing lots of data. Classifying groups of data so that we can look at inputs and outputs of production operations in ways that we hadn't looked in before. Clustering information. A lot of these techniques are now, I've heard the example over in some of my literature reading and some of the things even topical here today. Some of these analytics are the things we see happening with Google, and whether it's search engines. Somebody mentioned Netflix the other day. Good example of how a lot of these analytic tools are being used in the consumer world as well. So a lot of the technologies, maybe some of you have heard of them before, that they're just coming on to some of them actually may or may not make it. Neural nets is a big question mark in a lot of minds. It's very difficult to set up, but they have been used in some of these analytic tools. Self-organizing maps, genetic algorithms, decision trees, multivariate statistical projections, and pattern recognition. That seems to be a lot of emphasis being played in that particular area. So over time, with the use of analytics and bringing it into your operation, what we expect is to see knowledge discovery. Start to take the operator out of the loop and bring that knowledge and embed it, whether it's into the machinery itself or within the production control systems around the machinery. This will require certainly more data sensing. It'll require more intelligence in the machinery, for example, to even start to collect that data. So we have ways to go in terms of starting to build more and more knowledge discovery. In fact, I was just reading, maybe it was because I was reading another article just the other day. I hadn't brought it into this presentation. Oh, what did I do? Oh, thank you. It was talking about Toyota. We all know that Toyota is fanatical about the Toyota production system control techniques. And here's a comment it says about Toyota. It says, what Toyota has done is to accumulate past examples and data from the entire Toyota production group in a systematic, stratified, and electronic format, and then use office automation to analyze this, to derive answers to most problems and issues. But the author also says, the company has been spending 5 times what other companies do to collect data, with the result that nearly all problems can now be solved by using past data. This approach constitutes, in essence, an enterprise-wide application of data mining to improve a wide range of functions within Toyota, including product quality and reliability. So Toyota is moving past the use of SPC tools and the traditional technology that they've used up until now. And they're now moving into what I would consider is analytics. There are others that are starting to use analytics to actually embrace, to help some of the decision making from the use of SPC. So they're applying the analytics to develop rules of corrective action for the operator to make as a process may go out of spec. So in the future, not in the future, but now the way we look at it is analytics sits in the middle, in between what we on the top here is the production lines, the production machinery, the energy management systems, and some external events that are uncontrollable by many of you. But it sits in between the machinery and also PLM as well as production management. PLM is important because analytics can also be used to drive information back to the design of the product, back to the initial design of the product so that we actually can manufacture the product better. So in the future, what we're looking at is information-driven manufacturing. That is the extensive use of data, statistical and quantitative analysis to explain and predict and provide predictive models. So it's fact-based management. And this will drive decisions, it'll drive actions throughout the entire business. And analytics will be an input for either human decisions or drive more autonomous functionality within the machinery today, in the future. And I want to thank you very much for listening.